In this lesson, we examine functions of several variables, also called multivariable functions. In your previous studies, you primarily considered a function with a scalar input and a scalar output. Here, the horizontal coordinate of a point denotes the function's input, usually denoted by the variable x. And the vertical coordinate is the output of the function, typically given by y. We will now consider functions of more than one variable. This means we have more than one input. Here, the inputs are typically denoted by x and y, and the outputs are typically denoted by z. This picture shows an input of a point a, b in the xy plane, along with the corresponding output of z equals f of a, b. Geometrically, the output represents the height above or below the xy plane. Consider the example of the saddle given by f of xy equals x squared minus y squared. With an input of 2, -1, or x equals 2, y equals -1, we get an output of 3. This means that the point 2, -1, 3 is on the graph of our multivariable function f. The usual notions of domain and range still apply, except now the domain is a two-dimensional region in the xy plane. However, the domain rules you know and love remain applicable. For instance, an expression in the denominator of a fraction cannot equal 0. Also, the square root of an expression must be greater than or equal to 0. Expressions inside a logarithm must be positive. Of course, this is not a comprehensive list. Consider the following example using the top half of the sphere, given by the equation of f of x, y is equal to square root of 4 minus x squared minus y squared. Here, the expression in the square root must be greater than or equal to 0. Thus, the domain is given by the two-dimensional region of points x, y, such that 4 minus x squared minus y squared is greater than or equal to 0. This corresponds to the two-dimensional region inside a circle of radius 2. This is an example of a multivariable function involving a logarithm. Specifically, we consider the function logarithm of x plus y minus 1. The domain of this function is the two-dimensional region of points x, y, such that x plus y minus 1 is greater than 0. This corresponds to the two-dimensional region of points that lie above the line x plus y minus 1 equals 0. One staple from your earlier study of functions still holds, the vertical line test. That is, geometrically, a three-dimensional surface represents a function if every vertical line passes through the function, intersects the surface at most one point. Said another way, a surface does not represent a function if there is at least one vertical line intersecting the surface in 2 or more points. This completes the lesson on multivariable functions. You can look down to go to the main menu and select another lesson or demonstration.